Hey, this is Jeremy, and today we're going to be talking about cardiac output. Now, cardiac output is essentially how much fluid is getting pushed through your body in 1 minute, which is how much blood your heart is pumping out every minute. So what you wind up with is your stroke volume times heart rate is going to equal your cardiac output. Your stroke volume in a normal, healthy human adult is going to be approximately 60 to 100 milliliters for every time your heart beats. That is how much fluid that your body is sending out. Alright, now your heart rate in a normal, typical adult human being is going to be 60 to 100 as well. So if you forget what the stroke volume for a normal adult is, then you know that 60 to 100 and the heart rate is 60 to 100. And so what that does is that equals your cardiac output. So a normal cardiac output for a normal adult human is going to be 5 to 6 liters, which is going to be 5,000 to 6,000 milliliters. There is 1,000 milliliters for every liter, so we wind up with 5,000 to 6,000 milliliters. So if we have somebody who is an athlete, for example, and this athlete, what they do is they exercise a lot. They do a lot of cardio. So what we may see is their heart rate may be on the lower side. So they may have a heart rate of 60. So what we have is we have to do their cardiac output, or I'm sorry, their stroke volume may actually be a little higher because their heart is a whole lot healthier. So if their heart rate is 60 and they're an athlete, and their stroke volume is going to be, let's say, 90 milliliters for every time that their heart contracts. It is sending out 90 milliliters worth of blood. So what you have is you do 90 times 60, and what that gets you is 5,400 milliliters, which is going to equal 5.4 liters. And that is going to fall within that acceptable parameters. Now, if you have somebody who is a little bit sicker, and they're not necessarily living the healthiest lifestyle, or maybe they're a little bit older, what you may find is that their heart rates are typically going to be a little bit higher than everybody else's, or what you may expect. So their heart rate may be 90 most of the time. And if that's the case, then that is okay. But what's going to happen is their stroke volume is going to kind of coincide with it. So their stroke volume may actually be lower because their heart may not be as healthy, so it's not able to kind of work as well, which is going to their heart rate is going to compensate for that. So in this unhealthy person, you may have a cardiac output of 5,400 milliliters as well. And so again, that 5.4 liters inside this person's body is what's getting circulated every single minute. So, and that's an important concept to understand. Is so this is your healthy athlete, and this is your elderly, potentially. So elderly / sick patients. Okay, the only thing that really changes is their stroke volume and their heart rate, and those are the two big factors that go into maintaining cardiac output. Now, if you have somebody who is sick, okay, so somebody who's really sick, all right, so what you may wind up with is their heart rate may not necessarily, or their stroke volume may not be very high. And so this is whenever you're going to be getting into those septic patients. So their heart may be very weak. So whenever you get there to them, their stroke volume may be about 40. And if that's the case, then that's okay. Their heart rate is going to try to compensate for it. So let's say that they have a heart rate of 110 on the cardiac monitor, which is going to throw them into sinus tach. So what you wind up with is them having a cardiac output of 4,400 milliliters, which does not equal those acceptable parameters. So this patient right here, their stroke volume is going to be very, very low, and their heart rate is going to be very, very high. And so this tells you right off the bat that this patient is going to be very sick, okay, with that 110 heart rate and that 40 for their stroke volume. Now, something that's important to understand is we cannot calculate stroke volume in the field. We are only aware that it is something that exists. So if I have somebody with a very high heart rate, I know that their stroke volume is typically low, and that is going to indicate that they could be a sick patient. Maybe there is something wrong with the heart itself, and if that's the case, then we can correct that. Now, if you do have somebody who is an athlete who gets their heart rate up to 110, their stroke volume may not necessarily be diminished because their oxygen. They have a need for increased oxygen. They have a need for increased nutrients that's getting sent throughout their body. So something to think about is the heart and how it works is we have this law, and it's called Starlings Law. So Starlings Law, what it does is it's also known as the rubber band effect. So if you can think about it like this, as if you were to stretch a rubber band out and you were allow it to fall back into itself, it would have a much harder contraction than if you were to just kind of leave the rubber band alone. So the more force that you exert on that rubber band. So let's say that I have somebody who this is their heart, or this is their rubber band, and it gets stretched out this way. And so what happens is we wind up with a heart that is getting stretched, right? And so now what happens is, so you have what gets stretched out has to actually get stretched back in. And so what happens is this force that was exerted, this force right here, that force that gets exerted right there, that gets sent back in on the heart. And so what that does is all this fluid that your heart has in it, which is what is causing the contraction to begin, or what is causing the expansion to begin with, is how it's getting filled with fluid. All this fluid ends up getting sent out through the body, and this right here is your stroke volume. Now, so if you can think about your heart as a balloon, all right? So if you think about your heart as a, so the heart equals a balloon. So what you have is, if you have a balloon and it were to get deflated, it would have some air still kind of sitting in it. Okay? And so what that does is, whenever you go to try and re-blow up that balloon, it's going to be a whole lot easier for you to inflate it. So the heart is the exact same way. So every time that your heart contracts, so your stroke volume, it is not going to be sending out all of the blood that fills your ventricles. So what happens is this is actually going to refer to your ejection fraction. And so what happens is, every time that your heart beats in on itself, every time that your heart contracts, it is sending out blood. Okay, and again, so that is going to be your stroke volume, okay, which is going to be about 60 to 100 milliliters. Now your heart may be able to hold, let's say, 125 milliliters, or 130 milliliters, just depending on how big and how healthy your heart is. So what you have is your ejection fraction is what percentage of the blood that is actually in your heart, what percentage of that actually gets sent out. Okay, and so what you find, and they're able to do this with diagnostic tests in the hospital and everything. So that ejection fraction in a normal human, okay, is going to be 55 to 70%. So that means that if I am sending out 100 If my heart can hold 100 milliliters, then that means that my heart is sending out anywhere from 55 to 70 milliliters with every single contraction. And so your ejection fraction goes into a very, very important factor in maintaining cardiac output. Now, your ejection fraction can be diminished if you have an unhealthy heart, such as if somebody's had a myocardial infarction or a heart attack before. And so what you wind up with is their ejection fraction is lower. So if you hear somebody say that they have a 20% EF, okay, or a 20% ejection fraction, then that means for every 100 milliliters that their heart actually contains, they're only sending out 20 milliliters worth of blood every single time. And so these are the patients that you're going to see have a heart rate of 110 or greater, because those are your super sick patients. Okay, so anytime you see somebody who's tachycardic, take a second and ask yourself, why are they tachycardic? Is it because they don't have the fluid in their body? Is it because they're having a heart attack? Is it because they're septic? There's a million different reasons as to why this can happen. But the biggest thing is just understanding cardiac output and how it goes into maintaining your body's perfusion levels. Okay, so all of this goes in your cardiac output. So your CO, that is going to equal perfusion. So if you have good cardiac output, you have good opportunities of maintaining perfusion. All right, and so the big things to keep in mind are: understand that we cannot calculate stroke volume in the field. Understand that your heart rate is going to be indicative of your patient's health, but it is not necessarily a direct relationship. Your healthy athletes, those patients are typically going to have a lower heart rate than your sick patients, who are going to have elevated heart rates, or your unhealthy patients. And if you have somebody who is super sick, their heart rate is going to be very elevated. And all of this goes into maintaining this cardiac output between 5 and 6 liters. And if you have somebody that is falling below that normal limit of what's acceptable for their body, that is whenever we are going to start having some issues, and you're going to start noticing some decreasing in mental status and things like that. And so that's cardiac output.